everyone, this is Nikki Jackson, one of the adjunct instructors for Concord Career College Math 1320 College Algebra. As you see on the screen now, this is dealing with a particular expression taken from Module 5 homework. Please note that in Canvas, you will not see the homework, or it's not necessarily your grade in Canvas, but the topics that are discussed in the homework will be on your midterm, my apologies. The topics on your homework from Module 5 will be on the midterm, so make sure that you still complete the homework so you have a little bit more confidence and know the skills that are coming from this homework. So going back to this expression, you see that it has the answers provided for you right here. Then also notice that you have variables and exponents. So what I'm going to do is allow you time to actually look at this very carefully, and then I'm going to move up so you can see the other one as well. What you should notice is that both of these problems, and I'm afraid that if I zoom out you won't be able to see them as clearly, that you have negative exponents right here. So what I'm going to do now is move this piece of paper out of the way so you can actually see what I'm referring to with the variety of colors. So let me zoom out now. So here we go. So thank you for your patience, and my handwriting is just all over the place, but hopefully you'll be able to interpret it. So for the first one, in black, you see that you have x to the negative first power over y to the negative fifth power, all to the negative second power. So you got a power to a power. Well, be mindful that we know that two negatives make a positive, and when you have exponents raised to a power, you are going to multiply. So you probably can't read that, but hopefully you can decipher it just a little bit. Exponents raised to a power are multiplied. So we know that negative 1 times negative 2 gives you positive 2, and negative 5 times negative 2 gives you positive 10. So your overall answer for this particular one is x squared over y to the 10th power. Your next example, you see 3xy to the negative first power, and then you see y 4x to the negative second power, y7. So I'm easing that up. What we're going to do is that we're going to use the distributive property, but notice, unlike this one, you don't have a power raised to a power like you did for the first one. Everything is within the parentheses. So again, notice that there are no outside exponents. So in this case, we're going to add our exponents because we're going to assume that the multiplication is visible. So going back to the distributive property, what our coefficients, which are the numbers, we're going to have 3 times 4. And then for the x values, remember when I said we're going to add our exponents? So we have an x to the first power right here, because it's assumed this is an invisible 1. Over here we have x negative 2. So it's going to be 1 minus 2. For your y's, you're going to have negative 1 plus 7, because remember, we're adding our exponents. So once we combine all our like terms using distributive property in the power rule, we're going to have 12, and then x to the negative 1 power, because 1 minus 2 gives you negative 1. And then we're going to have y to the 6th power, because negative 1 plus 7 gives you 6. This is what we have right here. But if you read your instructions carefully when it's your turn to do it, it's asking you not to use negative exponents. So whenever you see a negative exponent, that automatically means the reciprocal. So we're going to flip it. The only thing we have to flip is this portion right here, not with the y, but just with the x's. So when we flip it, we have 12 y to the 6th power on top because all of those are positive, and then on the bottom is no longer negative because we did the reciprocal. For your next one, hopefully once again you can see what's in black. You have 7x to the negative first power minus 6x to the negative second power. Well, it's kind of confusing right here because remember what I just said about the reciprocals? You're going to have to flip all of that because you have 7 over x now minus 6 over x squared. So this is where all of that is coming from. So your first step was to rewrite it as a fraction. Note that the negative exponents indicate reciprocals. So now that I have that, one of the ways that you're actually going to simplify that you're going to have 7x minus 6 over x squared. That's the final answer. So let me inch up a little bit so you can actually see what's going on. And I'm going to try to zoom in. Well, right here you have subtraction. Well, let's think about that for a moment. When you add or subtract, you have to have the least common denominator. So in this case, your denominators are x and x squared. If you multiply those two together, you're going to have x cubed. So that's where that came from. Now we're going to do something called cross multiplication. So now we're going to have 7 times x squared. That gave you the 7x squared. And then we're going to have 6 times x. That gave you the 6x. That's what we have right here. But then we're going to simplify. When we simplify with the x's, these x's right here counter cancel each other out. Here's why. You have 3 right here and 2 up here. Well, we know that 3 is bigger than the 2. So this right here is gone. And then right here, the x is completely isolated. Here's a better understanding of it. So go to this part. We know that we got 7x and 3 minus 2 gives you the 7x1. So that's why you see 1x on the top. Then right here at the bottom, you have 6x, and then you have a 1 on the top, and then a 3 on the bottom. So that's 1 minus 3. So now we got 6x squared, but that's a negative 2. Rewrite that using positive exponents, and this is what you have for your final answer. I know that was kind of confusing, but please make sure you rewind and look at this again. You may also feel free to use MathWay. Your next example is dealing with scientific notation. So given to you in the green, you have 0.0005. Now, scientific notation is just another way of writing an extremely small number or an extremely large number. In this case, it's considered an extremely small number. So given to you, you're going to have a number with a decimal right here behind the first 0. But we want an imaginary or an invisible decimal. So let me zoom out just a little bit. There we go. So we know that 5 is my whole number, and these zeros are all place values. So you're always going to write your whole number first. Because our number system is a base 10 number system, you're always going to multiply by 10. But the trick is your exponents. Remember earlier when I said extremely small or large numbers? Well, since this is a decimal, you automatically will assume that your exponent is going to be negative. If this was not a decimal, you will automatically assume that your exponent would be positive. So now we have 5 times 10. Let's see where that negative 5 comes from. So you're going to move your invisible decimal to where you see it now. So in the problem, it's going to be behind that first 0, which is right here. But we want it behind that whole number. So once we move our decimal, we got 1, 2, 3, 4, 5, because it has to be in the front of it. But notice how we have negative 5. Your next one, still pertaining to exponents. Let me erase this. Is asking for your degree. This is kind of blurry right here, but hopefully you can see the 18. So I'm going to combine my like terms, and while I'm doing all that, I'm also going to be mindful of what the instructions are. The instructions for this particular example saying that the degree means the largest exponent. Well, we combine like terms. 4 plus 8 gives you 12. Be mindful that when we have the exponents that look alike, we're going to add them. So now we got 9 plus 9, 18. 9 plus y, and so that's 8 plus 9 is 17. So your 18 is the highest degree. So be careful with that, because sometimes you don't necessarily, and I said add, you got to be careful with that, because sometimes when you're combining your like terms, the exponents do not change. In regards to combining like terms, check this one out. So let me zoom out so you can actually see it. Zoom out again because there's a lot going on. Alright. So given to you in black, you have 5x squared minus x minus 2 minus 6x squared minus 10x plus 8 plus 11x squared plus 8x minus 6. So we got to combine our like terms with this one. So what I did was look at all the ones that have x squared with it. So I'm circling those. So look at this first part right here. We have the 5x squared minus the 6x squared plus the 11. So with all of those, I have 5 minus 6, which gives you negative 1. Negative 1 plus 11 gives you 10. Bring down your x squared. Still combining like terms, so now I have just my x value. So here's the x right here. That's a negative 10x, and that's a positive 8x. Well, notice this minus right here. That's going to be a distributive property. So now that's two negatives give you positive. So now I have negative x right here, positive 10x here, and a plus 8 right here. Notice how there's no negative out there, so that's why that comes down. So negative 1 plus 10 gives you 9. 9 plus 8 gives you 17. Bring down your x. Now we're dealing with our constants. Those are the ones without your variables. So we have negative 2, because you see that. This negative right here is going to make that positive a negative. And then this positive is going to make that stay the same. So when we combine our like terms, we have negative 2, negative 8, and negative 6. So negative 2 plus negative 8 gives you negative 10. Negative 10 plus negative 6 gives you negative 16. So here's your final answer. Notice how we did not change anything with the exponents for this particular one. So now we have this one. We're going to be using distributive property. And be careful that you're going to have, because we're multiplying, aka distributive property, we're going to add our exponents. So negative 7 times 2 gives you negative 14. X1, this is an imaginary or invisible 1. So 1 plus 2 gives you 3. There's no other y, but you do see the 1y. So that exponent is going to be 1. Your final answer, negative 14 x cubed y. Now we have something that's a little bit different. With the previous example, we multiplied. Now notice how it's given to you as a fraction. So the opposite of multiplication is a division. So since this is a fraction, we're going to assume that it's division. But also take note, unlike multiplication, we're going to subtract our exponents. Remember, when we were multiplying, we added our exponents. So we're going to divide everything. And here's what I did. There's no other coefficient, a number down here. So I rewrote the negative 36. To make it easier, I rewrote my variables with their exponents. So we had an x here and an x there. So we have 4 minus 2, which is this part right here. We have a y here and y there. So that's 7 minus 1, which is right here. And then we have the z's right here. So that's going to be 8 minus 3. So when we subtract them, because it's a fraction, we have negative 36, x squared, y to the 6th, and z to the 5th. Don't forget, that still says negative because there was not another coefficient there. Now we have another example, still using distributive property and adding your exponents. So with this particular one, whatever goes on the outside, you're going to multiply by each term on the inside, which is this right here. So 2 times 5 gives you 10. We're going to add the exponents. So this x1 plus this x1 gives you x2. That y1 plus this y2 gives you y3. Now be mindful, these are referring to your exponents. So I'm not saying powers. Bring down your plus sign. 2 times 4 is 8. x1 plus x2 gives you x3, and y1 plus y3 gives you y4. You may have noticed that none of the exponents were being multiplied. They were being added. Now in regards to the adding and subtraction of any type of exponent, we're still going to do a different form of distributive property. This is what we call the FOIL method. So in regards to the FOIL method, let me see if I can zoom in a little bit. FOIL is not talking about aluminum foil. FOIL is an acronym for first, outside, inside, last. Now some of you may remember this. So it was your first term within each set of parentheses times the outside terms on each set of parentheses. So look on the left and then look on the right. The inside of each set of parentheses and then the last term for each set of parentheses. So over here in black, I wrote those out. So I have x times x, which gives you x squared. On the outside, that's x times 10, which gives you 10x. On the inside, 7 times x would give you 7x. And on the last, 7 times 10 gives you 70. Now we're going to combine the terms. So I'm looking only right here. There's nothing that I can combine with x squared, so it's now gone. I can combine these two, so 10 plus 7 gives me 17x. And then with the 70, bring it down, and it is positive. So my final answer is x squared plus 17x plus 70. Here's another example pertaining to FOIL. Please feel free to actually pause and write down the actual terms for this. Now this FOIL is a little bit different because now you have an exponent. So given you have x minus 8 squared. So what that means is not multiply it by 2, but multiply it to itself twice. So hence you see the x minus 8 written twice. Using the FOIL method, once again I wrote out the first, outside, inside, last. So x times x would give you x squared. Then x times negative 8, that gives you negative 8 squared. Then negative 8 times 8 gives you negative 8 squared again. Then negative 8 times negative 8 gives you positive 64. So remember, two negatives give you a positive. My apologies for that. We're going to combine our like terms now. So once we combine our like terms, we have the x squared. Then we have negative 8 plus negative 8. That still gives you negative 16. And now we have the plus 64. So I'm crossing these out so as I write them down, you can actually see how we're simplifying. Now here's one. Take a moment to actually look what I did. Unlike the other ones, I still use FOIL method, but I want you to see what canceled out. So for your first terms, we did 3y times 3y, which gave us 9y. For your outside terms, it was 3y times positive 1, which gave you positive 3y. For your inside, that was negative 1 times 3, which gave you negative 3y. And then for your last term, negative 1 times positive 1, we know that a negative times a positive gives you a negative, hence negative 1. We have to combine our like terms. There is no middle term in this one. Notice how you only have two terms? Well, these two that is gone because there's nothing else that looks like that. But notice with the three y's, one is positive and another one is negative. So these are gone. You don't have a middle term whatsoever because it's 0. So you don't have to write it. And now we're left with negative 1. But wait, there's more. So let me get that out of the way, make it a little bit more visible if possible. So this, we still have a polynomial. And it's an expression. So we have 12x cubed y to the 4th power minus 39x4 y to the 3rd power. It's asking you to factor it. And factoring is very similar to division. So to make it easier, because sometimes division is difficult, we're going to have what is the greatest common factor, that's a GCF, for 12 and 39. So we know that 9 cannot go into 12. We also know that 1 can go into both of them, but that's not the greatest one. So if you think long and hard, and feel free to find a factor table, we know that 3 can go into both of these. Then we have to look at each variable very carefully. What is the smallest exponent for each variable? So my apologies for my penmanship here. So we know that we're going to have a 3 for 1, and then we're going to have the smallest exponent. So my greatest common factor literally is 3. So that's where this 3 comes from. Looking at your smallest exponent for your x's, so I got x third and x to the 4th. So x to the third is going to be my smallest one. I can factor that out. Because think about counting. In order to get to 4, you have to pass 3. So we got our x's. Then let's look at our smallest exponent for our y's. So my smallest exponent for my y's is also 3. So those smallest exponents for each variable were factored out right here. Here's where the division comes in. So if I'm dividing like this, I have 3x cubed y cubed. So I know that 3 can go into 12 4 times. That's where this 4 came from. Also see that my x's cancel each other out. So the x's are gone. And then regards to the y, 4 minus 3 gives you 1. So I'm left with 4y to the first power. So that's where that 4 came from. Now we're still going to do some more division. Let's do it right here. Now remember, the x cubed and the y cubed are coming from my smallest exponent. So now we have positive 3, so that's why you have that positive right here. 3 can go into 39, or negative 39, negative 13 times. 4 minus 3 gives you 1, so that's where that 1x comes from right here. And then the y's cancel out. So now I'm going to rewrite it. So notice how I factor both of them by the 3x cubed, y cubed. So I don't need but one of these, so they're gone. So that's why it's written right here. And then look on the inside of the parentheses. I have 4y. That's a minus up here, minus 13x. So this is your final answer right here. So let me erase the mark so you can actually see where that minus sign came from. So this is when you simplify it. So this is your final answer. Now we have this one. So let me cover up 15. So I was trying to do these pre-recorded and already write them out. So I won't use so much video time. Plus it's dealing with my memory. So right here, it's asking you to factor and simplify it and use a more appropriate way of saying it. If you notice that you have the same terms on the inside of each set of these parentheses. So that's what my little scribble scrabble right here is. Notice that the same terms are inside the parentheses. I probably can't spell either. So automatically I know that the 3a plus b is going to be part of my final answer. Now look on the outside of each set of parentheses. You have different terms. So rewrite what you see. You see 7x minus 2y. Just make sure you put it in parentheses. There we go. We have literally simplified it. So 3a plus b times 7x minus 2y is your answer. Now this gets a little confusing, especially if I have this all in the way. So let me erase that. Alright. So in blue, hopefully you can see it, is asking you to factor by grouping. Well, we have to be very careful when we factor by grouping, because you have to have the same terms in each set of parentheses. So right here, we see an AC. Let's look carefully. We don't have another AC, but we definitely have another C. Then right here, we have a BD. Well, we got another B, but we also have a BD and an AD. So, let's figure out how we're going to do this. If we were to factor out the A's together, which is possible, you have to make sure that you write that correctly. What I'm choosing to do is to choose the ones that have the same number and variables. So right here, we got a 2 and a C. Right here, we also got a 2 and a C. Here, we have a 7 and a D. And right here, we also have a 7 and a D. So that's why I was graphing them. I'm not graphing, grouping them like that. So we rewrote it, grouping according to the number in the variables. So right here, we got a 2AC plus a 2BC plus a 7BD plus a 7AD. Here comes the factor. Both of them have 2's and C's. So I'm crossing out the 2's and the C's in this one. I'm going to rewrite it down here, hence the 2C. I'm left with an A plus B. So hopefully you can see that, the A plus B. Over here, we have a 7 and a D. And over here, we also have a 7 and a D. Hence, that's why I actually wrote out the 7D. Look on the inside, you have a B plus A. Now, here's the thing about multiplication and addition. They're commutative. That's a property. Another way of saying community is reflective. So notice I got A plus B right here, but B plus A right here. They're the same thing. Just like 4 plus 3 is 7, and 3 plus 4 is still 7. They're still going to be the same thing. They're just reflective of one another. So you can rewrite these either as A plus B or B plus A. They have to be the same term. So on the outside, we got a 2C plus a 7D. And on the inside, remember what I just said, addition is commutative. I'm going to have an A plus B and then an A plus B right here. Even though you don't see that, it's still the same thing. So your final answer is 2C plus 7D times A plus B. I'm going to flip this page over now. We still have some more factoring by grouping. Once again, my apologies for my penmanship. Now, be very, 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 very careful with this one. Do not combine your like terms because it's asking you to factor. It didn't ask you to solve. These two are like terms. So again, do not combine like terms. What you're trying to do is combine them according to the greatest common factor. That's how we're going to group them. So let's look at this. We got a 3x squared and a 15x and then a negative 2x and a minus 10. Well, we have to find out what variables and factors they have in common. Unlike the previous one, we had numbers and variables that were alike. Well, this time, let's just focus on what we know, just basic multiplication. Well, according to this, I see a 3x, they have an x, and then I have a negative 2x. Now I'm choosing to combine those two, which you see right here, because this is a 15x and that's a minus 10. You should know that both 15 and 10 are factors of 5. Or 5 is a factor for both of them is the correct way of saying it. So I'm going to group them. So now I have 3x squared minus 2x. Then I have plus 15 minus 10. Here comes the factoring part. Both of these have x's in common. So if I take an x away from this one, I'm left with 3x. If I take an x away from this one, I'm just left with 2. So that's why it's like this. With these two, I'm going to divide them, which is also a factor, by 5. So 15 divided by 5 gives you the 3x. Bring down your minus sign. 10 divided by 5 gives you 2. But notice something. These two terms, or not terms, the items within these sets of parentheses are the exact same thing. So automatically, you know this is going to be part of your answer. Hence the 3x minus 2. Outside the parentheses, you see x plus 5, so that is your other factor. So the two factors of this particular problem were x plus 5 times 3x minus 2. Here's another way of factoring. With this particular one, we're just going to rewrite it. So we got x squared minus 20x equals 0. Well, we know that 0 doesn't mean anything, but we do see that both of them have an x in common. So when I rewrite that, I'm going to have the x on the outside. That brings down this x. Bring down your minus sign. And I'm going to take away that x from this 20, which comes right here. Remember, I don't need the 0, so that's good. Now notice how this x is completely isolated outside of the parentheses. Hence, you have this part right here, x equals 0. But over here, I have x minus 20. Remember that 0? I'm going to let it equal 0. In order to solve for x, I'm going to add 20 to both sides. So now, I have two answers. My answer are x equals 0, and then my other answer was 20. You're going to have to write this as an ordered pair, hence you're going to have 0, 20. Alright, we have another one. So hopefully you can see it. There we go. So my apologies for my penmanship again.
It's all over the place, y'all.
Okay. So given to you, you have a squared equals 8a. Well, I kind of want to factor this out in the form of a polynomial. So that means it has to be an equation equals 0. So I rewrote it. I have a squared minus 8a plus 0. Well, where did that minus come from? Well, that's kind of easy to show. I subtracted a from both sides. I can't combine them because one is a squared, meaning it has two a's, and the other one has one a. And you should see that it equals 0. Well, now that I've done that, I'm going to factor these two out. Notice that both of these have a's in them. So I'm going to take an a away. So now I'm left with a, bring down your minus sign, and the 8. With the previous example, we know that this a is going to be 0. Now, why did I write 8 right there? I don't know. And that color did not help me whatsoever. Maybe this one. But we know a is 0 because it's isolated by itself. And then we're going to solve for a right here by letting it equal 0. So add 8 to both sides. So now I got a equal. I still wrote the same thing down, didn't I? I did. My bad, y'all. So once I solve for a, I have a equals 0 and then a equals 8. So your final answer in solution form is a comma a. I wrote it down right and didn't show you how to do it. So my apologies, y'all. Your next one is pertaining back to something that's going to lead you up into module 6 and module 5. So let me get this out of the way here. It's asking you to factor. So I'm going to show you a link when we actually do our Teams meeting for this module, how to find the factors. So both of these are perfect squares. Now here's what I mean by perfect squares. What gives you 4? 2 times 2. What gives you 81? 9 times 9. So that's where you see these from. Also, the variables are perfect squares because you have x times x and then you have y times y. So this is how I broke it down right here. So the perfect squares are right here. So 4 is 2 times 2. 81 is 9 times 9. Because we have that using distributive property, and the way that we're going to write that, we're going to have our 2x right here, which is in your first set of parentheses, and then we're going to have another 2x right here, which is in your second set of parentheses. Then for your second terms, you're going to have a 9y right here, and then you're going to have another 9y right here. But pay close attention to your signs. Notice right here, you have a minus sign. Well, let's think about that. If we were to ever multiply, or when we multiply, we know that 2 negatives give you a positive. 2 positives still give you a positive. But a negative and a positive gives you a negative, and a positive and negative gives you a negative. So let me say that again. I think I said it wrong. We know that 2 negatives give you a positive, and we know that 2 positives still give you a positive. But when they're unlike signs, which is a negative and a positive and a negative, they still give you a negative. Well, right here, this 81 is a negative. So that means somewhere these both can't be negative and they both can't be positive. So one can be a negative and the other one can be a positive. The order does not matter because they're the exact same terms. Just make sure one is negative and the other one is positive. So here we go again with some more of my errors. So this one right here is still asking you to factor, but now we're going to do the difference of 2 squares. Well, difference, we know that means subtraction, and we know that because there is a subtraction sign We also know that it is a square because it's indicated by the exponent of 2. There's a general formula for the difference of squares, which I hope you can see in purple. You have a squared minus b squared equals a plus b times a minus b. Oops, tongue tied. So let's look at these. Hopefully you can see in the blue. Let me try to zoom in. And again, my apologies, I made a mistake here. Okay, hopefully you can. So with this part right here, I broke it down, and I call it expanded form because we're using FOIL method for this. So we have x squared plus 4x plus 4. So I wrote it out using FOIL. Then the next one, I wrote it out as well using 4. So that would be x squared plus 18x plus 81. Notice the minus sign right here. Well, now I can factor stuff out. Well, right here you have a minus x squared minus 18 minus 81. That means this x squared and this x squared cancel each other out. Now you have 14 minus 18x, which gives you the negative 14x. And then you have positive 4 minus 81, which gives you the negative 77. We're to factor this part out only. Notice that you have a greatest common factor of 7, because 7 can go in both negative 14 and negative 77. So we're going to make that a negative 7. So dividing, we're going to have negative 7 goes into negative 14 twice. Bring over your x. Bring over your plus sign, because we know that two negatives give you a positive. Negative 77 divided by negative 7 gives you positive 11. So right here, let me try it again. This is your final answer. So that's kind of difficult, so you might want to do extra practice on that particular one. We're still working with factoring. So with this one, we're going to factor out the 9 because 9 can go into itself one time and 9 can go into 36 4 times. So that's what I factored right here. Notice on the inside of the parentheses, this is again a perfect square, so we know what can give you 4. We also know we got the 2 x's. So with your 2 set of parentheses right here, here goes one x, there goes the other x. We know the factors of 4 are 2 and 2. Notice the signs are different because this is a negative. So we got one has to be positive, the other one has to be negative. Your final answer is 9 times x plus 2 times x minus 2. This one is very similar. Instead of having squares, we have something to the 4th power. So you might need your calculator for this one. Notice how I factored out and I broke it down. I know that 4 is created by having a 2, so I got my n squared right here and an n squared right here. I also knew that 25 times 25 gave me 625. So here goes a 25 right here, here goes a 25 right here. They are different signs because this is a negative. So I have a negative right here and a positive right here. But notice these are still squared. And here's how I know I can still factor. It's to an even power. So if it's 2, 4, 6, 8, on and on and on, you can keep factoring those. But if they're odd numbers, you get stuck sometimes because they actually are prime in some cases. When this one, I just brought it on down. The reason why I cannot factor this is not factorable. If I had 2 positive 5s right here, I would have had n squared plus 10x plus 25. Well, I don't have a middle term right here. So this cannot be factored at all. But this one can be factored because I know I see my 2 n's. So here's an n, there's an n. Here goes 25. So that's a 5, that's a 5. Because it is negative, that means one has to be positive, the other one has to be negative. So your final answer is n plus 5 times n minus 5 and n squared plus 25. But remember, because this is positive and does not have a middle term, it cannot be factored. Now here's what I meant by not being factored. You got 9x squared plus 16. Well, both of those numbers are perfect squares. Here's what I mean by perfect squares. 3 times 3 gives you 9. 4 times 4 gives you 16. But 3 is not a factor of 16, nor is 4 a factor of 9. So this is not factorable. You can't even factor out an x because this one does not have an x. Now that does not apply to all of them. Just for this particular example, it is not factorable because you do not have a common factor. I'm going to flip it over. Let me zoom out just a slight bit. There we go. Now we're going to factor using the difference of two cubes. Now earlier we did the difference between two squares. Well, this one similar, but yet different. We know that it's going to be the difference because we see the subtraction. We also know it's cubed because it's to the third power. So using this formula right here, we have a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Okay, well, let's figure out what's going on. You can't really see this green, so my apologies. But I gave you what a and b were. So my a is actually a itself. And the reason being, notice how this a repeats itself 3 times. So that was y. The same thing with the b is 3. So why is b 3? Well, 3 just so happens to be the cube root of 27. Here's what I mean. 3 times 3 is 9. 9 times 3 is 27. So substitute your values in for a and b. So a, just for this example, is actually a. My b is going to be 3. Now I have a squared plus 3 times a plus which 3 squared is going to be 9. So substitute it in and then simplify. You have another one, this is dealing with factoring, but another way of saying it is solving for x. So given to you, you have x squared minus 81. Well, I rewrote it and said x squared minus 81 equals 0. If I added 81 to both sides, I now have x squared equals 81. But 81 is a square. The square root of 81 can be positive or negative 9. So notice how you're going to have two answers right here. So when you write it, it's depending on what the instructions are asking for. You might have to write it out like this. But that is pertaining to a actual square root. And be mindful, square roots can be both positive and negative, because 2 positives still give you positive and 2 negatives still give you a negative. And here's even more dealing with factoring. So here's what's given to you. The actual expression is x squared minus 8x plus 15. So it's asking you to factor. But hopefully you can read my handwriting. If you can't, I'm going to decipher it for you. What can be multiplied to give you 15? But if you add it, it can give you 8. So I'm looking at my last term and my middle term. So what can you multiply to give you 15? And what can you add to give you negative 8? That includes both positive and negative numbers, which you see right here. So let's think about 15. What can you multiply to give 15? So I can get a 1 and 15. Then I can do 3 and 5. So if I added 15 plus 1, that gives me 16. If I subtracted 15 and minus 1, that would give me 14. Same thing if they were negative. Negative 1 minus 15 gives me negative 16. And then if I had 15 minus 1, that would give me 14. Now the next factors of 15, 3 and 5, they give you 15. So I can either say 3 plus 5 gives me 8. Or 5 minus 3 can give me 2. That also includes it whether it's negative or positive. Because you can say negative 3 plus 5, that can still give you positive 2. Or you can say negative 3 minus 5, which gives you a negative 8. Now we want a negative 8. Because that's what it says right here. Well, we know that 2 negatives give you a positive. So hopefully you can see my pencil running around. 2 negatives give you a positive. So that means we're going to fill in the blank right here. This is going to be a negative, and this is also going to be a negative. So you're going to have to do a guess and check sometimes with these terms right here. Meaning, look at this one. Let's do another example. Given to you, you have x squared plus 13xy plus 22y squared. Well, what can give you 22 if you multiply it, but if you add or subtract it, it gives you 13. So right here, I wrote it out. I know 1 times 22 gives me 22. I also know that's 2 times 11 gives me 22. Well, 22 plus 1, whether it's negative or positive, can give you 23. But 22 minus 1 gives you 21. We don't want 21. We want 13. Let's look at this one. 2 times 11 also gives you 22. So if I add it, it gives me 13. If I subtract it, it gives me 9. So this is the one that we want. So let's fill in our blank right here. So this is going to be, because we got 2 x's right here. So one of them is going to be a 2 in front of that y, because we got 2 y's right here. And the other one is going to be an 11. The question is, are they going to be positive and negatives right here? So a plus right here and a minus right here. Both of them positive, both of them negative. What? We don't know. Well, let's look at our signs. We know that 2 negatives give you a positive. Well, we also know if you add them, they're still going to be positive. So we can't use 2 negatives because this middle term was positive. We also know that a positive times a negative or a negative times a positive gives you negative. Well, that's not a negative. That's a positive. So now we're only left with one other option. We know both of these are going to be positive because look at your middle term. Lastly, we still have factoring going on. So this is going to be your last example. Feel free to contact me or send me screenshots, those who are actually enrolled in this particular class, or if you have any questions. This one is x fourth minus 5x squared plus 4. Well, for this particular expression, in the past, we've always gone to the second power. Well, now we have to the 4th power. So we're going to do it a little bit differently, but it's still factoring. The first thing we're going to do, we're going to rewrite it letting x squared equals x. Does it make sense? So look at your middle term. Well, if x squared is going to equal x, that means x to the 4 is going to be x squared minus 5x plus 4. The 4 had absolutely nothing to do with the x because there's no variable here. But we can break this part down. We know what gives you 4. 2 times 2. We also know that if we were to give factors for that, that's going to be a little bit different. So let me do the factor table again. Whatever we're looking for 4 when we multiply. But if we add or subtract it, it gives me negative 5. So we know we got 1 times 4 and 2 times 2. Well, if you did 1 plus 1, 4 plus 1, that can give you 5. If you subtract it, that would be 3. This right here is either going to be 0 or 4. Well, we wanted 5. So we know we're going to have to use 1 and 4. So here goes your 1, there goes your 4. But now we have to determine whether it's negative or positive. But notice right here, this is a positive. So if this is positive, that either means that it's either going to be a plus and a plus, so 2 positives, or 2 negatives. Let's look at our middle term now. What is your middle term? Your middle term is also negative. Hence, that's where these 2 negative signs come from right here. But there's still more to do. Remember, we substituted x as x squared. So now we're going to plug it back in. Rewriting this with this, we're going to have x squared minus 1 and then x squared minus 4. Well, these two can also be broken down. We know that the factors of 1 are 1 in itself. So here goes your x right here. That's 1x. There's another x. 1 is a factor of itself, so there goes a 1. There's another 1. Why do you see a plus and a minus? Because look right here, there's no middle term, so one has to be positive and a negative. The same thing goes for the 4. 4 has no middle term. Well, this one does not have a middle term, so we got an x and an x. It could be 4 and 1, but there's no middle term, so it's going to be a perfect square. Perfect square means that what gives you 4 just multiply it to the same number. So there's a 2, there's a 2. Once again, why is it negative? Because we have negative right here, so one is a positive, one is a negative. So ladies and gents, thank you for your patience. These were examples taken from homework 5 from Math 1320.